In this video, we're going to look at topic 64, example 2, where we reflect a function across the x or y axis. Part A, it says the graph f of x equal 2x minus 6. So we already have that graphed in blue. And the function g, we're going to put g in red in this case. Let's change that. Okay. Whose graph is a reflection of the graph of f across the x-axis. So this time we're going across the x-axis. And we want to know how are their equations related. So we already graphed f, it tells us graph f, but it's already there. Then graph g by reflecting each point of the graph of f across the x-axis. So what does that mean? It means for each point xy on the graph of f, we want to plot the point x negative y to get the graph of g. So we have this x-axis here, and what we're going to do is we can take any point along our f of x function, and we're going to reflect it across that axis. So the point, let's start here, this point here is 0, negative 6. If that's reflected across the x-axis, think of it as being mirrored. That 0, negative 6 would go at 0, 6 up here. All right, another point, let's say we have this point here. This is 1, negative 4. So that 1, negative 4 will become 1, positive 4 up here. And we would just keep repeating this process. We can reflect any point we want. So this point, 2, negative 2, would reflect across and would be up here as 2, positive 2. The point 3, 0 is right on the x-axis, so that's really not going to go anywhere, but you'll see that that's where these two lines intersect. You also have the points that are above. So this point, 4, 2, when we reflect it, it'll reflect to the bottom side. So that will go here at 4, negative 2. And you get the idea, but we'd have another point here and here. So I'm just going to draw a line connecting these. Get this as straight as possible. Hope that locks in. Let's try that one more time. It looks something like that. Close enough. All right, so we've now plotted g of x in this case, right? That's our function g. And they're asking how are the equations related. So looking here, since the y values of the new function have the opposite sign, g of x is equal to negative f of x. So if we notice, everything was flipped, right? We had 0, negative 6. The y value became 0, positive 6. 1, negative 4 became 1, 4. 4, 2 became 4, negative 2. So by reflecting across the x-axis, all of our y values changed. So the entire function, in this case f of x, we're taking the negative version of that function. So if we have g of x is equal to negative f of x, well, we know that f of x is 2x minus 6. And if we keep going, right, I can distribute that negative sign. I will get negative 2x plus 6. And if we wanted to confirm that, well, this here is my y-intercept, right? That's in y equals mx plus b. And this negative 2 is my slope. So I do, in fact, have a y-intercept of a positive 6. And my slope does go down, run 1 and down 2. So we have a negative 2 over 1, down 2 over 1. So this g of x function checks out. That's it. They're just asking how are the equations related. Well, effectively when you're switching or reflecting across the x-axis, your entire function becomes the negative version of itself. And I'll get back to that in a second after we've completed part B. In part B, they want us to do not necessarily the opposite of that, something similar. But this time, they're asking us the function h, whose graph is a reflection of the graph of f across the y-axis. So this time, we're going to reflect across the y-axis. So f of x equals 2x minus 6. That's the same one. We're still going to keep that in blue. And h, let's write h in green this time. So h will be in green. So what I'm going to do is I'm going to take any of my points, and I'm going to reflect them across the y-axis. So I'm going to pick this point here, 1, negative 4. And that's going to get reflected across the y-axis to the left. So that 1, negative 4 is going to become, let me make sure I put this in the right spot, negative 1, 4. That's supposed to be in green. Makes it a lot easier if it's color-coded. So negative 1, 4. I can pick another point. I can pick this point 3, 0. Instead of 3, 0, if it's reflected across the y-axis, it's going to become negative 3, 0. So notice here that our x's are going to be negative. And in the previous example, our y's were negative. So what does that tell me? Well, if I'm reflecting across the y-axis, my x values are going to change. So this was 3, 0. This one is negative 3, negative 3, 0. Keep writing in blue. This is supposed to be in green. Negative 3, 0. And I could pick any other points I wanted to. If I pick this point here, 5, 4, I would reflect that on the left side across the y-axis, and instead of 5, 4, that would be negative 5, 4. Because then we're changing the x values. So if I connect these, we get something that looks like that. Again, you'll notice that where they cross that y-axis, that's going to be the same because we're reflecting over the y-axis. And in the previous example, they intersected at the x-axis, and that's what we were reflecting over. So kind of keep that in the back of your mind. Here, since the x values of the new function have the opposite sign, h of x is going to be equal to f of negative x. And notice how here we have f of negative x, and up top here in the other problem we had negative f of x. So notice where that negative is and how things change. So if I take h of x, and that's equal to f of negative x, well, I know that f of x is 2x minus 6. So when I plug that in, I want a negative value. So I'm going to say 2 of negative x minus 6. And again, you want to compare, sorry about that, you want to compare these two here and ask yourself what's going on when I reflect over the y-axis and when I reflect over the x-axis. So this h of x value becomes negative 2x minus 6. And again, if we want to check this out, we can look at the slope and the y-intercept and confirm that those in fact match up. I'm quickly going to rewrite this in green because that was supposed to be in green. And the one above should have been in red, so I apologize for that. So h of x is equal to f of negative x. H of x is equal to 2 minus 6. So h of x is equal to negative 2x minus 6. And that's where we have this. So the x values, if we're reflecting across the y-axis, you'll notice that the x values are going to become negative, where in the previous one, when we're reflecting over the x-axis, the y value, the entire function itself became negative. Might seem tricky, might seem a little confusing, and a lot of like, oh, like I don't really know what's going on. This seems like a lot. It could be a little overwhelming, but it really helps to look at the actual graphs themselves and see, all right, I can see how this is reflecting and the y values are changing, or I can see how this is reflecting and the x values are changing. By comparing these two and maybe watching this video a second or a third time, it'll help you see that up here, when we're dealing with the x-axis reflections, the entire function is going to be changing. All right, you're changing the whole function as negative. Where down here, when we're reflecting across the y-axis, only our x values are going to be changing, not the entire function. So kind of look that over. If you have questions, obviously you should always ask them, and sometimes watching this video a second or a third time could help you out.